Hi guys, welcome to this video. We're going to have a look at the idea of what's called numerical integration. And the part that I'm going to have a look at here is to have a look at something called the rectangle rule. Now this is described also on page 214 of your workbook, and what I'm going to do here is to work through a particular example on screen here. Now I've got Graphmatica open here, and I've got a function which will just graph, okay, if I can. Okay, it's the graph of sine x divided by x. Now, let me just also start up the drawing tool so I can use that in a moment and just minimize that for now. Now, as you might see here, if you can look closely at the graph, there is an undefined point here where x equals 0, which should make sense. Okay, so sine of 0 divided by 0 would be undefined. And what I'm going to do is use Graphmatica here to show us an area that we're going to use a numerical integration method on. Okay, so if I click on this integrate tool and I highlight an area going from x equals 0.5 to 3, okay, what we've got here is an area that we want to find underneath this curve. Now if I just click on options here and go to Simpson's rule for a moment, sorry, I can't use Simpson's rule, let me just click on that one. Right, so the area highlighted in the sort of pinky maroon type color is about 1.36 units squared. Now let's not worry too much about how the computer is calculating that at the moment. Let's have a look at this thing called the rectangle rule, which is what we're asked to use. Now you might have seen when I had this first up that there were excuse me, a number of rectangles shown, and let me just go back to that for a moment. Unfortunately, with this piece of software, none of the methods which are given in this options here are actually the rectangle rule that we want. Okay, this particular one is using 5 different rectangles. Okay, but you might notice that the height of the rectangle is taken from this left hand edge here, and you might be able to see the area that we're getting, 1.58 roughly, is too much because all these sort of rectangles that are shown here have too much area. And if we went to using rectangles below, okay, you might see 1.12 is an area too low because we're missing out, and let me just try and show you that we're missing out on quite a bit of the area required. Okay, so this portion here and here and here and here and here, so all this area we're missing out on each time. Okay, so with this method described in the text, what it does is to actually take the midpoint to use as the place that we're going to use to calculate the area from. So let me go back to these various options we've got here, and I'll just change it back to calculate automatically. And so what we're going to do is, I'll just try and draw that on the screen. We're going to take a rectangle, but we're going to take the midpoint. Now the midpoint between 0.5 and 1 is 0.75, which will be here. And so what we're going to do is we're going to draw a rectangle that has that midpoint as its height. So let's draw that in as accurately as I can. Now you might be able to see that that rectangle is a pretty good approximation to the area we want. Now if I just highlight the area again that we want, or we're getting, sorry, with this rectangle. Sorry, that's a bit rough there, but not too bad. And if I just change the color there for a moment, you might be able to see that this rectangle misses out on this area here, but includes this area over here. And if you look, that doesn't look too bad. That area that we're missing out on this much is sort of almost equal to this area over here. And so if I get the area of that rectangle, it's pretty close to the area that I'm after. And if we have a look at the next one, I'm going to take the midpoint between 1 and 1.5, which will be 1.25, which is a point here. If I draw a rectangle out from that point and going down to there. Okay, once again we're getting not quite the area that we want, but something pretty close to it. This area in pink here that we're missing out on, we're getting this area over here in white, which is a little bit too much, I must admit, but it's pretty good as an approximation. So we're getting this area that we're going to add in, and then we're going to keep repeating that for, in this case, we'll do 1, 2, 3, 4, 5 rectangles. And so the next one would have a height of 1.75 and would go across the 2 there. So as you can see, I'm choosing to use rectangles which have a width of 0.5. You may be wondering, well, why do that? Why not use something which is more accurate? What happens if we had smaller rectangles? And that would be true. We could actually get a more accurate representation of the area that we're after by taking smaller rectangles. Oops, that's the wrong one. We want to take that midpoint there as being the area or the height of the rectangle we're going to use. Let me just tidy it up a little bit. So in this rectangle rule, we have to decide how many rectangles are we going to use. I've decided to use 5 rectangles here. And while we can choose to either use the top or the bottommost point of our rectangle, okay, as the height, in this method that the textbooks uses, which is called the rectangle rule, it uses the midpoint. So in this method that is officially called the rectangle rule, we use the midpoint of the rectangle to get the height of the rectangle. So the midpoint here between 0.5 and 1, and the midpoint between 1 and 1.5 would be 1.25. So that is going to be 0.75. This one will be 1.75. This will be 2.25. And the last one we're going to use here in this case, 2.75. So those midpoints are going to be what we're going to use to get the height of each of the rectangles. Okay, and then what we need to do is we need to take this base length and multiply it by that height then to get the area of that rectangle, and then repeat that for the other 4, so giving 5 in total. Now I've done that calculation over here on a spreadsheet that I'll just bring onto screen here. Okay, and so what we've got is 5 rectangles. The length of each of the bases is going to be equal to 0.5. Okay, so the width there, 0.5 for each of them. The midpoint, Okay, that's at 0.75, 1.25, 1.75, and so on. So here they are here. Now these heights, how were they calculated? Well, what we would do on a calculator is to take the function that we're graphing, which is in this case is sine x divided by x, and so what we would do is calculate the sine of the first one, 0.75, divided by 0.75. Don't forget to work in radians here, and if you do that calculation you get that 0.9088, etc. And then to get the area we multiply that width, 0.25, sorry 0.5 I should say, times the height we're using for the rectangle, which is this height here, which is that 0.90885168. So the area is the base length, 0.5, times the height of the rectangle, and that would give, in this case, 0.4544, etc., that value. Okay, so setting that out in a table obviously is a good idea, so we can keep track of those calculations in a sort of organized way. Okay, and for the next rectangle, the width, the base width would be 0.5, and the height of the rectangle is going to be what we get when we put 1.25 into this function here again. Okay, and so the sine of 1.25 over 1.25 would be that 0.7591 distance or height, and then the area of the rectangle would be that height times 0.5, giving this value here. And so we keep repeating that for the 5 different rectangles in this case, and that gives an answer of 1.3674. Now you might recall that the actual area was pretty much, if I go back to that, pretty much like that. So click on options here. Okay, calculate automatically, and let's do that, and 1.3517 is what we're getting here. And if we did the calculations on the spreadsheet again, I've got 1.3574. Okay, they're very close. Okay, so these two values, let me just highlight them again. This one here and this one here. Okay, very close. So that's a pretty good approximation for the area that we actually have underneath that curve. Of course, if we decided to get things more accurate, what we could do is we could change the number of rectangles to say 10. And let me just show you what that would look like if we did it on this spreadsheet here. Okay, and we just have to ignore all that stuff there for a moment. So I'm going to change the number of rectangles from 5 to 10. 6, 7, 8, 9, 10. No, that didn't work. So just change them manually. And the base width, of course, this time would be more. Just bring back that Graphmatica for a moment. If we had 10 rectangles, okay, the width of each of them would be from the first one 0.5 to 0.75. The width would be 0.25 this time. Okay, so let me change all of those to 0.25. Copy that down. The midpoint would be halfway. Okay, the first one would be halfway between 0.5 and 0.75. So it's actually going to be 0.5 plus Let me just do the calculation over here. So 0.5 plus 0.75 over 2, that would be that would be 0.625 would be the midpoint of the first one. Okay, so let's type that in. And then we'd have to calculate each of the other midpoints, and that's going to take a little bit of time, so I'm just going to pause the video while I'm doing that. Alright guys, so just coming back here after doing a bit of work in the background there. Okay, so what I've had to do here was to recalculate all the midpoints. So coming back to our graph, if we had, let me just clean this up a little bit. Sorry, this is mucking around here guys, which I sort of hate, but okay, let's just try and explain things a little bit better. So if we had 10 rectangles instead of 5, then the midpoints, let's see if we can just see what that would be for the first few anyway. Okay, so coming back to here, our first rectangle would be going down here. Now the midpoint is there, and so we would be having a rectangle looking something like that. Sorry, it looks so messy. Let me just try and tidy it up a bit. So going across like that approximately. Now what's that midpoint going to be? Well, that's 0.75 there, and that is that midpoint there. So you'd have to get it would be halfway between 0.75 and 0.5. So you could subtract those two and divide by 2, and that would give that 0.625 that I had a moment ago. Now, of course, you could also say, well, that distance between there and there, 0.75 to 0.5, is 0.25. Okay, so if I got that point there, 0.625, if I remember rightly, to get to the next midpoint, we could add on 0.25, which would give me this next midpoint there. Okay, which should be a rectangle approximately there. Okay, so that would be 0.625 plus 0.25. And just jumping back to the rectangle, sorry, Excel here, okay, that would be that 0.875. Okay, if we go back to the graph, 0.875 looks about right actually. Okay, so that's what I did to basically get these other midpoints here, and in the heights we substitute these midpoints into that function sine x over x, giving those, calculate the area, add them all up, we get 1.356, which is even closer to the actual area that we're after. Okay, so that's essentially how the rectangle rule works. Now, of course, a good table like this is what you need. So if you have a look on page 215, you'll see there that that's essentially how they're getting you to set this work out, except they're using far fewer rectangles than the 10 I've got here. I think the highest they go up to is 6. Alright. Well, hi guys. So what would I like you to have a go at? I know this video is going up pretty late, so rather than get you to do any particular questions at this stage, I'd simply ask you to make sure that you've read over the material and the example on page 214, and then we'll have a look at the rest of the material tomorrow in class, get you guys to have a go at some of the questions there. Alright, so we'll catch you there tomorrow, guys.